Snowball Earth and Stellar Metamorphosis. I took Snowball Earth. I got this 30-second theory book from the bookstore. Look for ideas in this book. Snowball Earth. Here's a picture of Snowball Earth. Sorry. Probably get copyright claims on that. But anyways, Snowball Earth basically means that the Earth was a giant snowball with a kilometer thick ice completely covering its surface. Now, why would something like that happen? Really think about it. Is it because there's too much CO2 in the atmosphere? Is it because the sun dimmed a lot and then couldn't heat up the Earth as easily? Lots of possibilities are here, but one possibility is sort of ignored by the establishment. It's because the Earth wasn't always orbiting the sun. The sun's a very young star, maybe at most 100 million years old. I'll go ahead and read this paper. I'm going to post it up on Fixer. It's not up yet. Snowball Earth and Stellar Metamorphosis. The multiple glaciations, the snowball Earths, on the Earth in the general theory are caused by orbit changes. In short, Earth did not always orbit the sun. It orbited other stars in the past. The sun is far too young, at 100 million years old, about, to have hosted the Earth at 4.5 to 10 billion years old, for Earth's entire evolutionary sequence. This fact of nature is brought to the forefront, and we are dealing with a transitionary star system, and have misplaced sun-like stars as being as evolved as Earth-like stars. What's great about this theory now that I have a few listeners is you guys already understand what's going on here. I don't have to repeat myself. Earth is at least 45 to 100 times older than the sun. The sun is not a 4.5 billion year old star, not even close. The reason why it was assumed the sun was as old as the Earth is because Earth orbits it now, and the sun was claimed by astronomers to have formed at the same time as the Earth. Of course, that assumption is wrong. The sun is the youngest star in our star system, and Earth is so highly evolved that it has formed and currently hosts life. We are talking two stars that are wildly different in age. One is very young, hot, and huge. The other is smaller, rocky, differentiated, and hosts life. It is totally unreasonable to assume that they are the same ages when they are so different in characteristics. Their physical and chemical characteristics are direct observation that they are not related to each other either via formation, nor are they even close to each other in age. This is understood as polymetamorphism. That being said, what exactly would have happened to Earth if it was wandering the vastness of space without a host before the sun adopted it? Well, in Earth's earlier life, it totally had enough internal heat to sustain it. This is evidenced by hydrothermal vents and creatures that survive in the deep ocean far removed from any source of heat from an external star. You have deep ocean life, man. No heat from an external star whatsoever. How does that stuff happen down there? Well, it directly contradicts the claim that you need a sun to heat up the deep ocean. You don't. Deep ocean receives no sunlight whatsoever. The Earth more than likely would have froze over completely on the surface for tens of millions of years until it was adopted by another hotter host. So basically, Snowball Earth means, yeah, the Earth can wander the galaxy and it can still sustain water oceans. No problem. It doesn't need to be orbiting a hotter host. A hotter host is just for surface life. And even then, I'm sure there's a lot of underneath the ice activity that would be occurring. Lots of different types of plants and animals can survive those conditions. Orbital mechanics will eventually show this to be the only possible scenario, as Earth had multiple hosts in its past, and according to the general theory, was a host itself long, long ago. It has even kept its closest orbiting object, the Moon, as it lost all of the gas giants and other stars that it had in its grasp. So this means when the Earth was sun-like, it also helped along other much older stars to evolve by ripping away their atmospheres at faster rates. And that's another branch to this. Since the Earth was a sun-like star, it itself was its own star system as well, and had gas giants and other Earths in orbit around it. So we're looking at a deep, 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 deep past. It's far beyond the imaginations of astronomers today. Their imagination, they can't handle stuff like this, but you guys clearly can because you're watching these videos. You already understand what's going on here. As well, glaciations on Earth did last for millions of years, and there doesn't need to be any extra mechanism invoked by the sun to make it happen. The sun just did not exist yet. As well, no ad hoc mechanisms are needed to explain why the Earth got cold either. It simply did not have the sun heating it up externally. So it's a very simple thing. But it's forbidden for the sun or for the Earth to have orbited another star in its past. It's forbidden. It's forbidden for the Earth to have been a wandering planet without a host, without anything heating it up. It's not allowed. You can't do that in astronomy these days. If you say anything similar to that, you get ridiculed and called a crank and a crackpot, and you don't get to have a career. But I don't have to worry about that. I can say whatever I want. There's so many possibilities now with the general theory that one cannot tell for sure what objects were orbiting which, and which objects made up entire systems. One should wonder why mathematicians would spend time splitting those hairs when the orbital characteristics and evolutionary sequences of all stars is totally unique, regardless if they follow similar transformation curves. It is suggested to mathematicians to not split hairs, but to follow the basics. Since Earth was orbiting other stars in its past, then those stars themselves would be more evolved by now themselves, and would not resemble sun-like stars either. The stars Earth orbited in its past are much more evolved than the sun. In fact, most of them are already well underway into ocean world stages of evolution. In short, Earth is really, 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 really old. Tens of millions of years is nothing for the Earth. It is thousands of millions of years. Multiple orbit changes are totally doable. And I'll take a break before I read this last paragraph here. I just spent a little bit of time drawing this out. This is 4 billion years of time, this whole graph. Imagine this is 4 billion years. See this little spot right here? That's 100 million years. That's how long I believe the sun, how old the sun is. Now look at how much more time has elapsed that the Earth has been around versus the sun. There's no heckin' way that the Earth and the sun formed around each other from the same material or are related to each other. We're talking two completely independent objects here. The fact that they orbit each other now is skewing astronomers' minds. They're sort of trapped in a worldview that doesn't make any sense. When in essence, it's pretty clear to me, and it's pretty clear to you guys, that the Earth is vastly older than the sun. There's no way those things are the same age. But the dogma took hold back in like the 30s and 40s, and we've been trying to correct it ever since. But I'm not going to talk about that right now. It is best to start looking at Earth as not always having been orbiting the sun. This also brings up an interesting point very early on in Earth's history. Did it have a twin orbiting it when it was in red dwarf stages of evolution? I mean, when the Earth was a red dwarf, did it have another red dwarf orbiting it around a really tight orbit? We've observed these before. Their red dwarf systems where a red dwarf would orbit another red dwarf within less than 5 hours. So insane. Can you just imagine that in your head? Two red dwarf stars orbiting each other within less than 5 hours. But that would be wild. So the question arises, when exactly do we then count Earth as a host versus a companion to a hotter, younger star? Do we count the brown dwarf to red dwarf transition as being the host to companion transition? What if Earth orbited a red dwarf pair? Like, so it isn't just one sun, they're orbited two suns, they're orbiting each other. There are systems out there which have many younger stars in orbit around each other. When it comes to glaciation periods, what if Earth was in orbit around a red dwarf, keeping it warm, And then that red dwarf, it was orbiting, lost the Earth, which then took up orbit around the object the red dwarf was orbiting. So let me say that again. When Jupiter was a red dwarf, what if Earth was in orbit around Jupiter, and then the Sun adopted all these objects, and Jupiter lost Earth, then started orbiting the Sun instead of Jupiter when Jupiter was a red dwarf? That's a possibility. So many possibilities, but one thing's for sure: the major glaciations on the Earth were not caused by variances in the Sun's output or extreme chemical changes on the Earth due to internal characteristics changing in an ad hoc fashion just to make up for their discrepancies, but to Earth simply changing orbits and being exchanged from star to star. And this is also due to objects having entered and exited the systems and being exchanged and adopted and tossed out. And of course, this is all possible because all these objects lose mass as they evolve. So their gravitational influences are get weaker and weaker and weaker as they evolve. And that's also forbidden to do in astronomy because they don't have the stars as actually evolving. They don't have them evolving into what we're familiar with because, they separate it in their minds. To them, the highly evolved stars are planets. Of course, my listeners already know this. But as the stars lose their mass, of course, they can exchange orbits. Of course, if there's another object that enters into the gravitational field of another object, it's going to throw everything off because of conservation of angular momentum and all that. Things get really complex when you start talking about celestial mechanics inside of the general theory, and of course, that's going to be a big deal in the future when I start working on that. Anyways, I think I made this video long enough. All right, y'all, take it easy.